Okay, alright, I'm going to pick up where I left off before. I'm going to talk through a couple of different distributions, then we're going to do an example. So basically there are a couple of different ways to compare data distributions. So we've already talked in class before about back-to-back stem leaf plots, which are very useful for comparing two small sections of very similar data. So you might do males and females for how many pets they have at home, things like that, that are two different variables but related to the same data set. So it's important when you're doing this that you follow a couple of rules. So you've got to have a common stem. There's no point in comparing, say, ages of the people in this class versus you know, how many times you've eaten toast in your life, because those two numbers are going to be completely different. They're going to be massively different. So you've got to label each data set clearly. Make sure that the reader knows what the two data sets are for. Include a key, which we've talked about before, so they know what is meant by the stem and leaf plot. So you might say 5 line 0 means 50, or 5.0, or whatever it might be. So the smallest one always goes close to the stem. So as you can see in the example here, the smallest value always starts at the stem and branches out to the bigger values, regardless of what size it's on. So yeah, that's just something to keep in mind when you're doing your back-to-back stem leaf plots. There's an example. I won't go into that too much. Similarly, you can do parallel box plots, which is another way to compare data. They follow a common scale, is what they have in common. And it's very easy to use this stuff to compare things like position, size, the ranges of the various things, the median. There's a whole bunch of things you can compare visually just by looking at the two groups. Alright, so here's an example. I know that it's already got the median and the IQR on here, but I've written out this data here. And it's comparing 1970 to 2010 in terms of male life expectancy in years in a couple of different countries. So what we'll do is I'll make sure that that mean and IQR are correct. But yeah. So if you're going to do it, you need to figure out how many values there are. I don't think it says on here, so I'll count them. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13 countries. If I want to find the median, I use 13 plus 1 divided by 2, which is 7. So the seventh value is the median. I've got 1. Remember the smallest values that come out of the stem, so 2, 3, 4, 5, 6, 7. So 67 is our median, which they had. And this side it's 1, 2, 3, 4, 5, 6, 7. So the other median is 76. Then if you do the median of each half, we've got 1, 2, sorry, I shouldn't count it that way. So our seventh value is the middle, and I know that because we had 13, we should have 6 on each side. So we got 1, 2, 3, 4, 5, 6. 6 plus 1 divided by 2 is 3.5, which means our Q1 value is between 3 and 4. So we've got 1, 2, 3, 4, so it's halfway between these two, which is 54 and 59 is 113 divided by 2, which is 56.5. 56.5. And then of the other one, we're looking at, which one was my 76? It's my median. So 1, 2, 3 between those two is 71.5. Now we get our Q3s of both data sets. 1, 2, 3, and 4, so that's 69. And 1, 2, 3, and 4, that's 80, which means our IQRs are, we have 12.5, and we've also got 8.5, which is weird because on this PowerPoint it doesn't say that, unless I stuffed it up. 1, 2, 3, 4, 5, 6, 7. Yes, that's right. 71.5. Oh no, it's supposed to be, my apologies. That is 79.5, which is why that's supposed to equal 8. Alright, so I stuffed up. Teachers make mistakes as well. Alright, and then from here I'm going to comment on the center and the spread. So for center we tend to use median, and for spread we use IQR. So to comment on this, you would say so this is a written answer. So you would say something like the median average life expectancy. My handwriting is terrible and my spelling is usually wrong, so I apologize. Throwing pens on the ground as well. Alright, the median average life expectancy in 1970 was lower at 67 years old compared to 2010 at 76 years old. So that's my comment on center. My comment on spread is looking at the IQRs. So you would say the spread of life expectancy in 1970 was higher at 12.5 compared to 2010 at 8. And then you would do just some sort of conclusion to draw from these two. So you could say over 40 years, median life expectancy, can't speak either, median life expectancy has increased by 9 years and has also become less varied. Okay, so you could say that's less, yeah, the range isn't as big. All right, and I know that that's a lot of writing, but that's how you comment on center and spread and draw a conclusion. All right, so I might stop that there for now.